Hi, I am Parthasarathi, working in telecom sector since more than 17 years. First of all, I would like to congratulate and appreciate Dr. V. Kumarswamy for his wonderful initiation, definitely which will help students community enormously. In this brief stint, I would like to give some what are the technologies utilizing in telecom sector, transmission technology. Especially, I will give some brief stint about transmission technologies in telecom sector. So before going to that topic, we all know the latest coin words like 2G 2G in mobile, 3G mobiles, 4G mobile, 5G mobiles. So what is this? What is this 3G, 4G, 5G in mobile? See, the difference is initially we focus on only voice communication. Now, as generations are changing, as technology is changing, as per the utilization, now the utilization is more on data. That means more utilization in internet. Nowadays in COVID period, we have online classes. To even primary school students also utilizing internet. So that data utilization is enhancing day by day. So the in 2G technology, maximum you will get 64 kbps only the in that 2G technology. In 3G technology, up to 8 mbps you will get, and in 4G technology up to 550 mbps you could get. That is the maximum. Practically you may get less speed. Sometimes in 2G technology hardly you will get 3 kbps for 10 kbps speed. So in 5G technology, up to 10 Gbps you should able to get. That means within few seconds you should able to download 2-3 hours movie. So as technology is changing, means the bandwidth as per the demand of the customer, we have to give the more bandwidth. So the technology is developing like that. So to support, to give the maximum bandwidth, the data bandwidth to the subscriber users, the transmission technology also should able to change or modify to support, to give that, to transmit that much bandwidth to the destination. So initially we have PDS systems. But before that, what is the media is required to transmit that much bandwidth? What are the different type media? We all know copper is one media, coaxial media is another media, microwave systems are there, satellite systems are there, and fiber optical media is there. So copper and coaxial, olden days we used to use this media. Nowadays in last mile connectivity we are using in some sector, some in violent communication we are using as a last mile copper media, but it has its own disadvantage of attenuation, or it is prone to theft, and its a limitation of bandwidth criteria. And microwave and satellite we are using, but in different terrain, based on the different terrain conditions we are using microwave and satellite. So all telecom industry, all everybody, each and every service provider using fiber optic as a media, but to transmit the bandwidth. Why? Because it offers infinity bandwidth. It can through that fiber we can transmit any amount of data through fiber. But what is the limitation? Only the end equipment is the only the limitation. Means the multiplexing, demultiplexing technologies, and how fast that equipment or electronic system should be able to process the data, error free processing the data. So that is the only the limitations of utilizing the fiber optic media. So initially we have PDH systems, plus synchronous digital hierarchy systems. Initially we have only 8 MB systems. That means maximum it can transport up to 8 Mbps through that fiber optic. So even though fiber optic having an infinity bandwidth, maximum it will transport only 8 MB because of the end equipment limitations. So 8 MB system, 34 MB systems are there, 140 MB systems are there, and 500 plus some system also there, but maximum 140 system is only the popular at that time. So The another limitation is it support only the linear path. Means suppose any fiber cut happens, means traffic will not switch over to the another path because of its limitation in the technology in the PDS systems. So it supports only linear structure. After that, some SDA system has come, synchronous digital hierarchy system has come. In that SDA system, initially it will support that frame structure it supports 155 megabits per second. That is the initial frame structure of the SDH, and it supports ring fashion also. Means one set fiber cut means traffic will drive to the another path. So that is the main advantage of the SDA system. Initially in PDA systems, that feature is not there. So the first support is STM1 frame structure 150 mbps, and after that STM4 has come. After that STM16 has come. STM16 is 2.5 gigabits per second. Next STM64 has come, 10 gigabits per second. After that STM250 is also, but maximum STM64 only the popular utilization. In the SDA system, maximally initially only voice to it will carry only voice. The design of the system supports only for carrying the voice traffic. So initially that Ethernet traffic, it is not meant for, initially it's not meant for transporting the data traffic, IP based traffic. So next generation SDH system also has come. It could able to transmit Ethernet data, IP traffic also, but because of its technology limitations, QoS parameters are not as routers, switches, IP based switches, IP based routers, because of it, because it's initially designed meant for voice communications. Even though next generation SDH has come to support Ethernet over SDH. After that OTN systems has come. Before that DWDM system is there, dense wave division multiplexing. In the technology, suppose you know the wavelength multiplexing, because not different lambdas, you know the concept of lambda. In DWDM system it supports there are 10 channel, 40 channel, 80 channel DWDM systems are there. Means lambda systems means each lambda supports 10G. Let us say if I assume if you talk each lambda is 10G, there are 80 such type of systems. Let us say there are 80 STM64 systems are there. 80 STM64 means, so it could be able to multiplex 80 10G systems into the single fiber. That is the DWDM technology. So utilization of the fiber is more in DWDM. Suppose if I use a STM64 as the end equipment for the fiber, maximum 10G or STM256. But if I multiplex 80 such systems by using DWDM technology, I could able to transmit 80 into 10G, 800G I can transport through DWDM systems. Because how it is happening, normally for each lambda in fiber optic media we have three different windows are there: 850 window, 1310 window, and 1550 window. Window means 1550 window means it will support that individual lambda may be vary from 1535 to 1565 approximately. So to that window we are using to transmit different lambdas, lambda 1, lambda 2, lambda 3. So because of this wavelength division multiplexing, we could able to use maximum bandwidth. It has its own limitations also, DWDM. So after that OTN system has come, optical transport network system. In this OTN system supports mesh structure. That is the one of the main advantage of the OTN system is it supports mesh structure. Means suppose a source to destination, I could able to give four or five maximum paths we can give, like not one path, two path, three path, four paths also I can give. If one path is break means another path traffic will change. Even if that path is break means another path it will take. So customer will get 24/7 365 days he will get bandwidth without any disruption. That type of QoS was developed. And another advantage in OTN system is it could able to carry the traffic of voice, data, and whatever the frame structure. That's how that system was designed now. So everybody in telecom industry are using OTN. They're exploring the OTN technology to give the best quality service to the all subscribers. Nowadays, another feature is for OTN technologies. Initially in DWD system, individual lambda supports only 10G. Now this present OTN system, individual lambda supports 100G. So if I use a 80 lambda system, 80 into 100G data it can transport. So voice communication, communication, whatever the data frame structure, voice structure, it could able to transmit. So that is the present. Now we are using OTN technology. So whatever the technology, the basic parameters of signaling systems, DSP, and they are not changing. So if we focus on the basic fundamentals, we can adapt to the any type of technology. Thank you.